Okay, good day to each and every one of you. We have here another sample problem for determinate beams, or rather determinate structures. We are tasked to solve for the axial stress on member CD. And member CD is a cable having a diameter of 0.5 inches. And this solid bar, A to B, has a weight of 300 pounds and an applied load here at point A equivalent to 500 pounds, and the distance between from this applied load 500 pounds all the way to the center point of this member AB is about 3 feet, and then 3 feet again from point C all the way to point B. And the problem gave us an additional data, which is the diameter of this cable CD is equivalent to 0.5 inches, and the weight of this bar is equivalent to 300 pounds. So our task for this problem is to solve the axial stress imposed here on the cable CD. Okay, so that would be our problem. So let's go with solving this problem. It's a bit simple. You just need to look for the force being imposed here on our cable CD. So what we're going to do is to draw the free body diagram of this whole structure. Okay. We are like using the method of sections for this point. And upon doing that, all you need to do is to draw the beam, rather the structure. Let's say this is the beam. Goes like this. And here we have the 500 pounds going downward. So that's 500 pounds. We have here at point C. So this is A, this is C. And here at point B, this is a pin. Let's assume that at the x direction, it moves like this, going to the right, and along the y-axis going down. Let's say this is r sub b, and this is sub y, r sub b sub x for the horizontal and vertical, because we all know that the pin supports a structure if a force is acting on it along the x-axis and at the y-axis. And let's go back here in the problem. We have this structure C to D, so that's the cable, is connected here at this point. So it goes up like this. And since this is a cable, it should always be in tension. So the dimensions from A to C is 3 feet. And then from C to B is also 3 feet. This one is 3 feet. And this one also is 3 feet. And don't forget that the cable is angled. Okay, the cable is angled, so for the x slope, okay, for the x value for the slope is equivalent to this length, so that's 3, and for the height that is equivalent to 4, okay, 4 feet. And getting the hypotenuse of this portion of the right triangle, that should be 4 squared plus 3 squared, so that should be 25. Square root of 25 is simply 5. So we already have this free body diagram. And don't forget, we have the weight. We have the weight of the bar equivalent to 300 pounds. And where should we put that 300 pounds? Obviously, it should be at the centroidal axis of this whole structure, which is here at the midpoint. Okay. That is where the weight of that bar is concentrated. So this is 300 pounds. And this one is also 500 pounds. So all we need to do is to solve first for this P sub CD, because we are tasked to solve for sigma sub CD, so question mark. And before we can solve for the stress imposed here on our cable, we must first find the internal force that is being generated here in our cable. So we're going to look first for P sub CD. And that's fairly simple. We just need to apply the moments, the principle of moments, summation of all moments. And the very ideal pivot point for this one should be at the portion of this member having the most unknowns. If we can eliminate those excess unknowns, then we can just simply solve for our required. And for this example, we have here 500 pounds at point A. We have 300 pounds here at the center of center of mass of this member AB, or this solid shaft. At C, we have here P sub CD acting at this point of our bar, that is the center, angled at this slope. And we have here the pin that is supporting the structure, going to the horizontal axis, going to the right, and then going down for the vertical. So if we're going to apply the summation of moments, then we must use the pivot point having the most unknowns, which is at point B. So let's do that. The summation of moments rotating clockwise is positive. Moments at B, which is this one, so equals to 0. So by doing that, that should be cancel everything here because this is our pivot point. We have 300 pounds. The perpendicular distance is simply this 3 feet. So it rotates counterclockwise. So that should be negative 300 pounds. Let's retain first the unit so that we can save space. Multiplied by the perpendicular distance equivalent to 3 feet. And we have 500 pounds rotating again counterclockwise, so negative 500 multiplied by the perpendicular distance 3 plus 3, that is equivalent to 6. And we have simply the y component of this P sub CD going up, so that should be plus P sub CD multiplied by its slope, which is equivalent to 4 over 5 because we only need the y component. So that should be 4 over 5 multiplied by the perpendicular distance equivalent to 3. Okay, let's see, put it here, times 3. And solving for P sub CD, let's isolate everything so that the remaining parameter is this one, P sub CD. Let's transpose this 2 to the left side. By doing that, it should be like this, P sub CD multiplied by 3 multiplied by 4 over 5. 4 over 5, okay, that should be 4 over 5 is equals to transpose from negative becomes positive. So this one is 900 plus this one 6 multiplied by 5 is simply 3000, right? 3000. So upon simplification, it's all about just basic algebra. Simplifying, P sub CD is equals to 3,900 pounds divided by this. You can just simply do it like this, then 4 over 5, or you can get the reciprocal of this one, which is 5 over 4. And simplifying everything, P sub CD is equivalent to 1,625 pounds. So that's 1,625 pounds. And since we have a positive answer, meaning that our initial assumption that this is in tension is correct. So that's in tension. That's why we got 1625. But the problem wants us to solve the actual stress imposed in our cable. So we already have the internal force inside that cable, and the problem gave us the diameter of the cable, which is equivalent to d sub CD is equals to 0.5 inch. And since the cable is circular shaped, we just need to apply the basic area for the circular geometrical shape, which is pi d squared over 4. And upon solving for the stress, I'm just going to remove this one. Just going to delete this so that we can have some space. So applying the area, so area of a circle is equivalent to pi d squared over 4. And the next one is that we apply simply the formula for the stress. Sigma is equals to P over A. Okay, so let's do it. Just going to border this one. So sigma sub CD is equals to this one, 1625 pounds. 1625 pounds divided by pi. The diameter is 0.5 inch. So that should be 0.5 inch squared divided by 4. So sigma sub CD is equivalent to 8,276. 8,276 point. As much as possible, you should round it off to 2 decimal places. 0.04 psi. So 0.4 psi in tension. So this is the actual stress that is being imposed in our cable CD from this problem. So it's equivalent to 8,276.04 psi or pound per square inch. So that's why it's in psi.